So let us see that we can have to find the values of the labeled currents using the Kirchhoff's laws. So how should we be able to make use of the Kirchhoff's laws if this is the case? So now this is the circuit with the two loops. We have this one is the loop 1 and this is the loop 2, as you can see. And on the same point, we have 3 labeled currents. We have a current I1, and which is flowing in loop 1, and we have the current I2, which is flowing in loop 2, and we have the current I3, which is flowing in this actually branch. And all these currents are meeting at this point. This is a junction. So now, according to the Kirchhoff's junction law, it states that the current entering the junction is the same as the current leaving the junction. In that case, then we'll have on this junction, we'll have the current entering the junction, which is I3, and is equal to I1 plus I2. That's the state of affair. That is Kirchhoff's current law, or said to be junction law. As it states that the current leaving the junction is the same as the current entering the junction. So take note of that. And this is the very important equation you have to understand as well. Let's say this is given as the equation 1, because we're going to make use of it, just have to take it note. But I'll remove it, I'll keep it somewhere. So for the sake of space, I'll do that, but for you should have to keep in mind, as it would be the very important as how to make use of. So bear that in mind. Now we have loop 1 as well as the loop 2. In this case, we should have to assign the direction of the current in each loop as the way the direction has been given. Now in this case, in loop 1, the current flow is in the clockwise direction. Hence, we'll have to do it like this. So in this case, we'll have to indicate it as this. So this is the I1 flow in the current in the loop 1. And the current 2 in loop 2 is going like this. So we'll have to indicate it as anti-clockwise direction. Hence we'll have it as I2 in that case. So let's start with loop 1. We should have to apply the current, the Kirchhoff loop law in our loop 1. What is the current flow in loop 1? We have it as I1. Then what are the resistors that are found in loop 1? We have 34 plus 47. We'll have to sum up them, and we have it as 2. And we are done. Then do we have any resistor which is within the loop within the loop 1, which is being transversed, or in which a current from the another loop is passing through? We have it as 47 as well as the 2. So now in this case, we'll have it as a negative 47 times the current, which is I2, minus, now should be 2 times current I2, now is equal to. Now, do we have the source of power in the actual loop 1? Yes, we have, which is this one. Now, according to the direction of the flow of the current, which is clockwise, it means the current will have to enter through the negative terminal to the positive terminal, or to the positive terminal of the battery. If that's the case, then we say a voltage gained. It means the battery is being charged, so have it as a positive 45. So had it been that the current is flowing from the negative terminal, should be from the positive terminal to the negative terminal, could be voltage drop. That could be a battery discharge, or could be given as the negative. So that's the principle behind all this. Then with the calculator, I'll just have to sum up 34. So should be 34 plus 47 and plus 2. And of which you have it as 83. So have 83 I1 and the minus. These are in fact like terms, so which means we'll have it as the negative 49 I2, which is equal to 45. Now this is given as the equation 1, so keep that in mind in that way. And I'll go into root 2 as well in the same case. So we should also have to write the same. We'll have it as now root 2. So what is the current flow in loop 2? We have it as I2. And what are the resistors? We have a 2 plus 20 plus 2 and a plus 47. So what are the resistors that are being transversed by another current from the other loop other than I1, actually other than I2? We have a 2 as well as the 47. Now we'll have it as negative 49 times the current which is given as the I1. That will be equal to, now do we have the source of voltages, the source of voltages in the loop? We have this one as well as that one. So let's have to trace up the flow of the current. So the current will have to enter through the negative terminal to the positive terminal of the battery. That is the voltage gained. We'll have it as a positive 85. And in this case also the current will enter through a 47, will enter through the negative terminal to the positive terminal. That is also the voltage gained. So we'll have that and as that. Then I'll have to simplify. We'll have 2 plus 20 and that plus 2 and that plus 47. We can have it as 71 I2 minus 49 I1, which is equal to, now what is 85 and that plus 45? So we'll have that one as 138. So we can have it as 138. So this is the given as equation 2. So keep that in mind. Then we should have to solve those 2 equations simultaneously, in the sense that we can use even a substitution method or elimination method can be okay. But let's use the substitution method. It should be elimination method. So in this case, we'll have, let's say, 83 I1 minus 49 I2, which is equal to 45. Then which means I also have to bring this. So I also have to bring this one as well, but I should have to arrange the currents to be in the same line. So in this case, we'll have negative 49 I1 in the plus 71 I2, that which is equal to 130. That's what will happen there. So in that case, we'll have to eliminate, let's say we should have to eliminate I2. So which means we should have to multiply this one by 71 and this one by, let's say, 49. That will work. So which means we'll have 71 times 83. 71 times 83, we'll have it as 5893. So have it as 5893 I1 in the minus. Now 71 times 49. 71 times 49, that will be given as 34. So have it as 34. 79 I2, that will be given as, now 71 the times 45. So have it as 3195. So have 3195, and I should also have to multiply that one as well. That is 49 times 49. So 49 times 49, we can have it as 2404. So we have 24, so should be 01 in the minus, or have it is should be plus 34 79I2, and which is equal to, so now 130 times 49, so 130 times 49, so have it as 6370, so 6370. So that is the principle behind all those. Then we should just have to, now in this case, so let's just have to remove this. Then we're going to add the two equations, because I understand that upon adding the two equations, then I2 will automatically go. And had it been that this was the negative, it means we could have had subtract the two equations. So now in this case, we'll have to add the two equations, and we should have to indicate that we are really adding here, so have a plus sign there. So in that case, we'll have a 5893, so 5 should be that of 5893, and plus 24 01, we'll have it as 8292. So have 82. Now I should have to use this ink, and to keep in track, should be 82 94 I1. By the way, you should have it as I1 here, which is equal, because here will be given as 0, so it will be equal to, now I have 31 and 95 plus 63 70, so which means we'll have it as 95 65 in that way. Then we should just have to make I1 as the subject formula there. So in this case, we'll have it as I1 is equal to, then I'll have it as 2. So in this case, we'll have it as 95 and 65 should be divided by 82 94. So that will be given as, should be now about 1.15 amps. So that is the value of the current actually I1. Then I should have to substitute I actually into the other equation for actually I1. So in that case, we'll have it as 83 times I1, which is now have 1.15, and minus, so minus 49 I2, which is equal to 45, and that will be given as, should be 83, and in this case we'll have negative 49 I2, which is equal to 49, actually 45, minus 95.72. that is for upon having the product of that. So now we have negative 49 I2 is equal, now what is that minus 45? So now which means we'll have it as the negative should be 50 point, let's say 72. So in this case we'll have, now we'll have it as, what would be the I2, then you just have to simply divide both sides by, so in this case we'll have I2 is equal, now for 9 that way, so which means we'll have it as a positive, now should be positive 1 point, we can have it as 0.4 amps. So that is the value of the current I2 in that case. Then now first you have I3, we'll just have to simply substitute into the first equation That was according to the Kirchhoff, should be according to the Kirchhoff'S junction law. And that now we can have it as this. So in this case, we'll have it as, and of course, if the directions are not being given, we can choose any sort of directions. So we can choose to have whichever the directions. Strummer, the answer will be the same. Only that you experience some kinds to be a negative, but that would be the same way as well. So what would be the, we have the formula I3 is equal to I1 plus I2. So in that case, we'll have I3 upon having it as 1.15 plus 1.04. Should be in amps. Of course, it has to be in amps. That will be given as, it should be plus 1.15. We have it as 2.12 amps. So that is the kind of flow on the middle branch. So now, if that's the case, then it means across 34 actually ohm resistor, the current flow is I1. So from this section up to the whole of this one, the current is the same because it is a part of the series circuit. And while across the whole branch here, the current flow is that of I2. But the current across this branch is given as I3, which is given as that. So which means you can be able to have the voltage across this one using the Ohm's law across this, as well as even the power. So you can also be able to have the power at each and every component, as well as the energy. You can also have to have the electric energy if we are given the specific time. So that's how the Kirchhoff's law can be applied in this case. So now let's say this is a circuit. Now the question says that using the Kirchhoff's laws, find the value of the labeled currents. That is I1, 2, as well as the I3. And we can also have to calculate the voltage across each resistor. Let's say the power, actually electric power, and even the electric energy as well at each and every component. Let's say within 2 minutes. So you should also have to try to have the electric energy in that way. So now we have two loops. This is the loop 1, loop 2, and we have 3 currents that has been labeled in their respective directions. In loop 1 we have a current I3, in loop 2 we have the current I2, in the middle branch we have the current I1. So now according to the Kirchhoff's actually a junction law, this is the junction of interest. So which means according to the Kirchhoff's current, actually a current to junction law, actually the current entering the junction is equal to the currents leaving the junction. So which means we have 2 currents that are leaving the junction, and we have this current entering the junction. So take this one as the equation 1. You should have to keep in mind. So I've taken it out. We'll use it later, by the way. So now let's start with in our loop 1. So what is the current flow in loop 1? Now assign the direction as the way the direction has been assigned. So in this case, which means this is the direction, and this is the I2 because this is the current flow in the loop 2. Now we'll have this having it as I3. Of course, if you tend to have the opposite direction, answer could be the same, only that only that the direction. So let's say if we tend to choose the direction to be the otherwise, if this is the case, then instead of having I3, let's say as a positive 2, we'll happen to have it as a negative 2. So the answers will be the same, only that instead of having a positive, we'll have it as a negative. Instead of having a negative, we'll have it as a positive. That's the one thing that one, but the answer could be the same. And if we happen to have if we happen to have the negative answer, it means the direction was supposed to be the otherwise, but that's the principle behind. So what is the current flow in loop 1? So we have it as I3. So have I3 times. What are the resistors to loop 1? We have 120, then we have 74, and we have 56. And what are the resistors out of these? And that are being transversed by another kind from the other loop. We have it as 6. So have 56 times that kind, which is I2, and I is equal to. Now what are the polarities of the battery? And with respect to the flow of the current. So in this case, the current enters the negative terminal to the positive terminal. That is the voltage gained. So which means we'll have it as 5.8. So that's the only voltage that we have in the battery, in that particular actually. That's the only battery we have in that particular loop. So have 120 plus, should be 74 plus 56. So have it as 250. So 250 times I3 minus 86 I2, which is equal to 5.8. So now this is equation 1. And how about in loop 2? Now loop 2 we have the current flow given as I2, which is that of 25 and the plus 56 and the plus 110 and the minus what is the current being actually what is the voltage and being transversed by another current from the other loop. So it is the same as 56 now, which is times I3. So have I3, which is equal to what is the we have the battery in the loop, we have it as this one. And if it happens that in the loop we do not have the battery, it means we'll have equal to 0 if the battery is not available in that one. According to the Kirchhoff's loop rule, we'll have it is equal to 0. So looking at the polarities, it means it means the current will have to enter through the positive terminal to the negative terminal. That is the voltage drop. So have it as a -3. So keep that in mind. Now in that case, we just have to simply simplify according to the algebra. So that can be given as this now. So now have 25 plus should be 56. Yeah, should be 56 plus 110 like that. So have 191. So have 191 I2 minus 56 I3, which is equal to -3. So now which means we have two equations. This is the equation 2, of course, and we have this one as well. And by the way, this should be given as equation 2, this one should be given as equation 3, because equation 1 was that of the junction law. And of course that's the thing. So we have this equation, and we also have this one as well. Let's just have to combine them. So which means we'll have negative 86 I2 plus 250 I3, which is equal to 5.8. So now that's the principle behind all those. Now we just have to simply use the elimination method. Now for this time, let's think of eliminating I2 first. So which means we'll have to multiply this one by, let's say, -86, and this one by should be 190. That should be 181. But let's think of multiplying that one by positive, so that we should just have to add the two equations. Since we have a positive here, this one will be given as the negative. So I understand you know what is happening there. So now we have 86 times 191. That is 164 and 6. 164, 26. Now should be I2 minus 86 times 56. We can have it as 4816. That is I3, which is equal to the -3 times 86. Now we have it as -258. Now have a -164 and 6 I2 in plus. So what is 91? Actually 191 times should be 250. We can have it as a 47. 7 should be 50 I3, that which is equal to, so now 121 times now should be 5.8, that is 1107.8. So keep that in mind. Then now we should just have to add the two equations, in the sense that we'll have it as, this is we just have to, so we should have to indicate that we are adding the two equations. Then we'll have negative 48 16 and a plus 47 750. So that will be given as a positive 42 and then 934, that is I3, now which is equal to, now have negative, so what's that, negative 250, should be 258 and the plus, that is 1107.8. now that will be given as 849.8. so that's the principle behind that. Then I will just have to simply have I3 being equal to, so have that one divided by 42 934, or have it as a 0.0, let's say 2 amps. So should be that is the value of the I3, that is 0.02 amps. So I3 is given as 0.02 amps, that is the value of the I3 in that case. So we need to have I2. As far as the algebra is concerned. So the main week is to know how to come up with those equations using the Kirchhoff'S loop rule. Then the rest of the parts is Tuesday. It's just a matter of the algebra. So keep that in mind. So in this case, we should have to have I2. Let's think of using the second equation. It means we'll have negative 86 I2 plus 250 times 0.02, which is equal to 5.8. So what is that one? We'll have it as negative 86 I2 plus, now should be 4.95, which is equal to 5.8. And you have negative 86 I2 now should be like that. Is it that of I2? Should be, where am I getting 86? Actually 86, and of course that's the way to go. Where is this 86 coming from? And we are using the second equation, by the way, which is fine. So now, which means we'll have it as 5.8 minus 4.95. So we'll have it as this. So have it as, now should be negative 86 I2 is equal, now should be negative, now should be 0.85, should be 2, like that. And what is the I2? Then we just have to simply divide both sides by 86. So which means we'll have it as 0 point, now should be negative 0.00. Now you just have to have it as this, negative 0.01 amps. So that is giving us I2. Then to have I1, the current on the middle branch, you just have to simply use the first equation, that is I2 is equal to I3 plus I1. That is according to the Kirchhoff's junction law. So you'll be able to have that out at your own. Then from there you can be able to have the voltage across here, even the electric power that is also here. And the voltage across, actually the current across here, which is I1, you can also be able to get it from here. You'll be able to make use of that on there. So take note of that. And also here in the same note, the current across here, it is I2. So that is, we can also be able to have the power across 3 volts battery, because we understand that 3 volts battery and we have the current flow. We can be able to have the power there using the Ohm's law. It can also be in the same way as well, but that's the principle behind. So sometimes you can also, let's say, being given that, find the current across, let's say, 120 ohm resistor, given that the current across 56 ohm, let's say, has been given as, should be, but I haven't used 86 somewhere, but I don't know where that 86 was based from. Anyway, just have to have a follow-up if the calculations were correctly done, but I'm not so sure how did I use 86 instead of 56. Somewhere I've missed it. I don't know if I'm just being confused, but somewhere 86 has been used instead of having 56. But just have to follow up the algebra the way I've worked out with these values. But just have to know that. So let's say we are told to have, let's say we're told to have the voltage across 120 ohm resistor, given that the current across 56, let's say, it is given as 2 amps. So in that case, it is already been given that if this is the case, then the current across this branch will be given as 2 amps. So which means, according to the Kirchhoff, should be actually junction law. On that formula, we'll have I2 is equal to I3 and plus I1. In that case, it means I1 will be given as, so I3 plus 2 I2. So which means above all, we already have the value for I1. So that's the principle behind that. So take note of that. Or else, if we are being told that the current across 74 ohm, but actually a resistor is given as so, it means I3 will be given as that value. So you should have to understand that and up to. And what if we have a circuit with three loops? How should we be able to go over that one? So mind you, I've said that if it happens that we are being given, let's say, a circuit, and let's say the direction of the currents are not being given, you can use any directions you may choose to. So tomorrow the answer will be okay. Let's say we are told that or else if we have been given the directions, and if you may think of using, let's say, the direction which is opposite to that one, so tomorrow answers will be the same, but instead of having negative, we'll have it as a positive. Instead of having a positive, you have it as a negative. But that's the way to go as well. It is the same. Or actually only that if the current is negative, it means the direction was supposed to be the other way around. But that's the principle behind. Let's say we have this kind of a circuit. Of course, you have to continue it at your own time. That is, let's say this is the circuit. Fast. Now we have it as this. Let's say we have it as this. Let's say that's the case now. Yeah, it should be like this. And now this is 80 volts battery. Let's say this is 70, should be 70 ohm resistor. Let's say this is 20, this is 360, now this is, let's say, 40, we have, let's say, 200, and let's say this is 80. So now the question says that we should have to calculate the current across each resistor in this case. So we have 3 loops. This is loop 1, 2, as well as the 3. So what is the principle behind all this? So we're not being given the direction of the currents, but since we have 2 loops, up to 3 loops, it means we'll have to make use of the 3 up to 2 junctions, in the sense that we have this junction and we also have this junction. So in that case, we may think of having the direction of the currents, let's say having I1 going over like that. Let's say we'll have I2. Let me just have to use this. Let's say this is I1, we'll go like that. Let's say we'll have I2, that will go like that. Then I'll have, let's say, I3, that will go like that. Then we'll have, let's say, I4, that will go like that. Then we'll have I5, that will go like that. So that's how you can have to make use of that and up to. So now, what are the equations with respect to the junctions that I'm having? So which means the current entering the junction I1 is equal to the current leaving the junction I2 plus I3. So this is equation 1. Then we go on to this actually a junction. The current entering the junction I3 is equal to I4 plus I5. So this is graded as equation 2. So keep these equations in mind. Then now let's apply the Kirchhoff's voltage law in the loops. So we have the current flow in a loop 1 given as I1. In loop 2 we have it as I3, which is this. In a loop 3 we have it as I4, which is this. So that is. Now let's start. In a loop 1 we have I1 flow, and we have 200 plus, now should be 80, and the minus, now we have 80 which is being transversed by another current from the other loop, so which is given as 80 times I3. So yeah, that is the which is equal to, we have the source of power. With respect to the flow of the current, it means from the positive terminal to the negative, that is the voltage drop. So which means we'll have it as the negative 40. So in this case we'll have it as 280 I1 minus 80 I3, which is equal to negative 40. Now this is equation 1. Actually should be equation 3, of course. In loop 2 we have I3 which is flowing. In that case we have 80, should be that, and a plus 20 like that, and that is, then actually then minus 80 is being transversed by another current other than that one, which is 80 times I1, and the minus 20 times I3. because it should be I4, because 20 is being transversed by this kind, which is I4 from the other a loop. So should be that, in which is equal to, we have two voltages. Actually, we have two batteries inside there, so have a negative terminal to the positive terminal, that is the voltage gained. So that will be given as the positive 360, and also negative terminal to the positive, that is the voltage gained. So which means we'll have it as a plus 40. So also have to simplify it in the sense that we'll have it as this. So now which means we'll have it as, now should be 100 I3 and the minus 80 I1 and the minus 20 I2 should be I4, which is equal to, now should be 400. So let's say this is equation 4. Then let's go into, now should be loop 3. Now loop 3, we have I4 which is flowing, so resistors we have 70 plus, now should be 20. Now have minus 20, I should be 3, so which is equal to, we have a current flow from the positive terminal to the negative, which is a voltage drop, so have negative 80, and also like that, that is also voltage drop, so which means we'll have it as, should be negative 80 minus a 360 in that case. So keep that in mind. So in this case we'll have it as 90 I4 minus 20 I3, the which is that, and is equal to, so what is negative 180? So it should be negative 180 the minus 360. We'll have it as negative 44. So now this is given as the equation 5. So keep that in mind in that case. So in this case we have the first equations. So in this case we should have to, we have this equation, and we have 90 I4 minus 20 I3, that which is equal to negative 44 so in that case. And we also had the first equation from the first from the first loop, of which I removed it out, but what was that one? If I may recall, we had it as, now should be 280, it was 280, so 1 minus 80 I2, it was this, and which was equal to, now it was negative 40, it was like this, so like should be that. So now we have should be I3, so should be I3 like that, it's equal to negative 40. So we have should be these three equations with three unknowns. We have I3, I1, I4, I3, I1, I3. So let's have to produce the two equations with the two common unknowns, and so that we should have to apply, we should have to solve using simultaneous. We should have to solve using the way we solve simultaneous equations. So let's think of, let's say, making I1 as the subject in this equation. And if we make I1 as the subject, it means we'll have to substitute it into the first equation. Where there is I1, we'll have to substitute with what we got from that one. then you see that you have two equations, which is this one and the other equation, with a common two unknowns, that is I4 as well as the I3. Then afterwards you'll be able to have the value of the I1 using the same equation or whichever the equation that will give you I1. And from there you'll be able to substitute I1, I4, I3 into these equations. That is I1, I2 plus I3, and also in this one, this which is given as I3 is equal to I4 plus I5. You'll be able to have I5, and in that case using I1 and also I3 we obtained. We'll be able to have I3 as well in the same way. So try to have that one at your own time and do the way I've explained to you. Of course, you can also look over some cases how you can be able to solve for those unknown currents with whichever the way you may come across it, but that's the best way I can have to actually tell you in that one. So keep that in mind.